Thanks for joining me today, Ivan. This is Ivan Rouzanov. I'm Tim Mishak here talking with you. And I just wanted to talk with you about, you've got a lot of experience in the industry. I wanted to hear about what you do. I know you do a lot of debugging in your job. So first, tell me a little bit about yourself.
Yeah, so I work for Intel, although here I obviously represent just myself, right? Not the company, and everything I say is just my views and my opinions. I do indeed do a lot of debugging, and I'll start with the current and kind of go backwards, I suppose, right? So. Um, what I do for Intel is, everybody knows where we make processors, right? And everybody knows we make computer systems that work with Windows. And when you create new things, right, there's new features, and they need to be supported by the operating system. So inevitably, we work close with Microsoft, developing, co-developing those things, right? There's operating system support. There is new processors. Often there's new features on the platforms, so therefore new drivers, new firmware features, all this stuff, right? So all that needs to be put together. Somebody tests it, and then it doesn't work, right? So occasionally, especially when you deal with a pre-release kind of things. Anybody who develops technology, doesn't matter hardware or software, deals with that, right? Nothing is ever comes out perfectly first time. So you know things don't go as planned. Systems crash. The problem with that is that um, it's very difficult to determine whose fault it is, right? So in Windows world, um, we have those things, people call them blue screens, right? The system crashes. The correct term is like different operating systems call it differently, right? Like in some operating systems, this is known as kernel panic. Windows is very brave; it never panics. Instead, the correct term for that is a bug check, or as you know, you undoubtedly know, but maybe for some of your audience, it will be new. And the kind of difficulty is that for performance reasons, if you look at modern operating systems, in privileged mode, right, in what's known as a kernel mode, it's a shared address space. So it's very difficult to say, there is no, unlike in the user space, right, there's no address space separation, there's no protection provided. And so because of that, it's very difficult to say when you have a crash, system stops running, whose fault it is. Is it the operating system? Is it the device driver? Is it the firmware? Is it maybe a processor, right? And we have in those prototype systems, you have pre-released boards. You can have broken memory, broken SSD, everything could be broken. So it's very hard to tell whose fault it is. So we have a team of people which I run, and that's kind of what I do on a daily basis, which we look at those crashes and trying to figure out, who's to blame, right? So basically, when people ask me what I do, I debug Windows crashes and hangs, or rather, I should say, crashes and hangs that occur in Windows environment, because more often than not, they actually caused by device drivers and various third-party components rather than operating system itself, although that sometimes happens. So I've been doing that for Intel for a little over 10 years. And before that, I actually used to work for Microsoft. Most recently, I was writing parts of OS kernel, some parts of device power management, and then before that, I used to work for a team which at the time was called Windows Serviceability, and that's the people who make a computer reboot every few weeks, right? So people who write Windows hot fixes, security fixes. We used to have those things called service packs, right? So that's what we do basically. A team which fixes actual Windows bugs. So I used to be on that team for a number of years, and basically debugging, actual Windows. Um, all this years, right? So I've been debugging in Windows environment in kernel mode uh, probably about 18 years or so. And then if you look overall, I've been always interested in debugging and doing some sort of debugging, reverse engineering or whatever, almost 25 years at this point. And that's actually the most interesting part for me. And so like I'm a software engineer, but I call myself debug engineer because I predominantly just debug things. So that's kind of my main thing.
Oh, that's cool. You know, I've seen there's actually like quite a few different types of jobs that are really focused around debugging, and they're not really all the same. You know, I've talked with folks on you know on the Microsoft side where we have escalation engineers. So I've done a video with Jason Epperly, who's an escalation engineer at
Yeah.
Microsoft, and their whole job is around debugging too. And so I'm sure there's some overlap, but at the same time, I think it's you know completely different goals of what you're trying to do. Um, you work on a lot of like early hardware and figuring out some of the integration problems between the hardware and the software. Is that part of what you do?
So yeah, there is indeed a lot of overlap, and in fact, skills translate pretty well. Couple guys on the team that I run are actually used to be escalation engineers at Microsoft, and so
Okay.
they joined me, and then couple guys used to work for Windows Serviceability, so which
Yeah.
the guys escalation engineers work with on Microsoft side. So there's a bit of overlap. We do work indeed with a lot of prototype kind of pre-released things. Some of the things we work with, they actually don't even exist in hardware. They just completely simulated. We have a software simulation environments, and we uh, can run device drivers and firmware in operating system in unmodified form on in the simulation and actually find some interesting problems with that as well. So there's a prototype things, then there's a things which are released. For example, it may be coming from a customer, which is about to ship a new computer system. Um, Things like that. And then occasionally we also deal with the things which happen in a wild. With even with end users, we have in Intel we have our own kind of internal telemetry and our own internal sort of dog food program, if you will, which often happens on released hardware. We have various customers. You can have, especially on enterprise side, people might be running older versions of Windows, older versions of hardware for various reasons. Server systems tend to have a longer lifetime. IoT systems tend to have even longer lifetime. So um, there is all of the above. I used to, when I joined Intel, I used to get bugs on Windows XP, and I had to debug Windows XP, which I called cruel and unusual punishment. But eventually that luckily went away. So there is kind of big variety of things, right? And this is maybe um, like one big difference between, let's say, escalation engineers and what we do is that typically we work with stable hardware. Escalation engineers work with stable hardware. You can trust that your processor is doing the right thing. In our case, there is no such guarantee. You can have, let's say, a simulation environment, and simulation environment is just a software program. It can, like any software, it can have a bug, and it can do something strange, right? And so there is those kind of things. There is a big overlap, very similar tools, very similar approaches. That you basically is our God. A God. We pray to you and we worship you because you make important tools for us, and we use those tools on a daily basis. That's Windows Debugger is the most important tool. 99% of the time, that is what I use. Debug, a crash or a hang using Windows Debugger.
Do you do a lot of live debugging, or is it mostly on crashes?
So that's a big difference. Again, when I was in WinSC, I had a number of cases pretty often when I would have an actual repro, right? So we would
Mm,
reproduce a system or a problem, and we might be able to do a live debugging. Here, I would say it does happen, but 99% of the time, what I deal with is a memory dumps. So I get memory dumps um, from the crashes which already occurred, and I just debug them post mortem, and so that's a little bit different kind of environment because you have to kind of go backwards and see, pick up some what we call breadcrumbs and see, what might have, or prove rather, what have happened um, based on the various observable kind of memory artifacts, um, and kind of go backwards, to figure out, what it is. Another big difference is when I worked for Microsoft, um, in WinSC, the sort of an interesting thing was that the problems what we would get in WinSC would come to us from escalation engineers. And escalation engineers are amazing at their jobs. And when they send us a problem, it was almost guaranteed that it was a bug in Windows. We just had to figure out what was the bug, root cause it, and actually fix it. Um, the So that kind of had advantages and disadvantages. And one of the big advantages is that you have your private symbols, you have your source code, and all that stuff. And you do have somewhat kind of familiar technology areas that you work in. You tend to work in the same areas. Um, However, at the same time, there's a big similarity with what I do today is that in WinSE and today, the code that you deal with, you didn't write that code. Usually, you have no idea that it existed until you open this dump. You don't know how it works. You don't know why it works or how it's supposed to work, and your job is to figure out why it doesn't do what it's supposed to do and does something strange. The big difference for me now is that very often I don't have, I only have public symbols. I don't have source code. I look, at the disassembly predominantly, and I have to just, figure out. Basically, I do reverse engineering and use occasionally reverse engineering tools. Try to figure out, what happened. But the big advantage is that, and when I say I actually had to fix a bug, so I have to root cause and fix a bug.
right.
And now, very often, I can narrow down and prove that it occurs in a particular ingredient, and I can prove it's caused by this driver, for example, right?
Right.
And then
Right.
I can hand it off to that driver writer and explain it to them. Hey, you have a deadlock here, right? But I don't have to find out what is the root cause, and I don't have to fix it. So,
Yeah.
so
Yeah.
in many ways, this is simpler, and in many ways this is harder. So every job has its own hard parts and easy parts, I suppose. But there's, like, you're right, there's a very big overlap, very similar tools, very similar approaches. um, I used to look at memory dumps a lot in WinSE, and now I pretty much only look at memory dumps. It's pretty rare that I get to debug something live, set breakpoints and things like that. Although when it happens, it's usually a good thing because um, I can kind of observe things as they occur, and use some of the cool features as far as breakpoints go, and other things.
Yeah, yeah. So, it's definitely a different mentality that I'm sure you have to have when you're debugging things. You're not debugging from source, and there's an aspect of you didn't write this, but there's also the aspect of you don't even have the source code. You're debugging it from assembly. Um, and of course, even harder, right? You're working from a crash dump, and you
Yeah.
mentioned sort of there's these breadcrumbs that you follow back, and the breadcrumbs that you're following, I have to assume, are even harder to follow because you don't know the code, you don't have the source code available, and so you're I guess, what information are you looking for? Like, what kind of breadcrumbs do you find? Are there patterns that you see?
So you're trying to look at what the code does as far as memory, what usually, um, I call them interface points. So you can tell a lot about what code does by um, what APIs it invokes, right? So when you see, let's say you look at device driver and maybe it's a third-party device driver, right? So I don't have symbols for it. I don't have source code. It's not even from our company. It's not from Microsoft. I know nothing about it, right? But I can see it calls some kernel APIs, some WDF APIs, right? So those are documented. Data structures for them are documented. So I can see immediately the intentions of that driver. What is it trying to do? And I can say, okay, it's trying to do this, right? It's used with, this data here, and if it if it made a call to this API, then it appears to set this flag in this data structure, right? So then I can go check memory and say, okay, is it actually set or not, right? If it's not set, then likely we didn't go for this code path. So you use, a coworker I had at Microsoft who taught me a lot, Brian Perkins. He kind of said you have to adopt this mentality where on one hand, you sort of allow for any possibility. You don't assume anything, but at the same time, you need to kind of have a big X and be able to chop off really big branches very quickly to say, okay, that's not possible. This could not happen, right? Because the evidence doesn't support this, and try to narrow it down. And it's very interesting mentality in a sense that um, when you look at the source code, and everybody, I'm not an exception from that. If you write your own code, I don't, everybody who does that, we all experience this strange phenomena, right? When you look at your code, you read your code, and you don't see anything wrong with it, right? You go, in like when I used to write like a kernel code, for example, right? We would have code reviews, and I would always try to prepare myself as much as I can, right? I'll print it, read it multiple times, go sleep, then next day try to read it again, and try to find anything. And then you go to code review, and you're certain it's pretty good, and there's some smart people there, and they find some interesting bugs, and it's always somewhat disappointing, and it's a strange phenomenon. You look at the source code and everything looks good, right? And so you would think, like, if you don't have a source code and you just look at the crash dump, it ought to be a lot harder. And in reality, surprisingly, sometimes it is not. Sometimes I look at a crash, and I can reverse engineer and figure it out from assembly. And there's some good tools as far as reverse engineering goes, like Hexrace, which allow you to kind of decompile back to C-looking, pseudocode, right? And you can pinpoint a bug pretty quickly because you starting from the point you already know there is a bug, right? You don't need to be convinced, you don't need to reason, is there a bug here, does this work correctly? No, you already know for sure it doesn't work correctly because I'm staring at the crash, right? So
Right.
all I have to do now is to come up with some sort of reasonable hypothesis how this could have happened, and then attempt to find evidence of that, right? And luckily, I'm not in a court of law, right? I don't have to prove this beyond reasonable doubt, right? All I have to say, look, I think there's a race condition here, and I can show you how you can access this from multiple, threads, right? And I can also see that you're not protecting it by any locks, right? And so,
Right.
so
Right.
you have a write here, you have a read here. I think it's just a race condition, right? And that's what happened, right? So there's this kind of thing. Sometimes there's really cool tools, that are available. like for driver developers, for example, right? Driver verifier is incredible tool, which is built in the operating system. And um, people sometimes ask me, is that something new? It is. It's only available since Windows 2000, so it's been released in 1999. But it's an incredible tool, and it helps a lot. And very often you can, for example, show somebody, hey, that memory that you access in here, you also in your driver freed it in another thread, right? So this is use after 3, right? And I can prove it using driver verifier logs right in the debugger, right? Now I don't have to find out the root cause. How does it, why does it happen, right? But I can prove that there was the same driver which allocated memory, same driver which freed it, and now is trying to access this after it's been freed, right? So it's, becomes a lot easier in those kind of situations, right? So sometimes it sounds very, very difficult, but there's a lot of technologies available in the operating system, which Windows Debugger and various Windows Debugger extensions. This is kind of an interesting thing that people look at the Windows Debugger and they get kind of a little bit intimidated. It's maybe not. It's a maybe steeper kind of learning curve than something they're familiar with, like Visual Studio, right? And so they kind of get a little bit intimidated. And what we're not aware of is that there's a whole world of debugger extensions, which allows you to look at the memory or various artifacts or various um, tracing abilities inside the operating system, which gives you enormous power. And if you know what you're doing, if you know what you're looking for, if you know your tools, you can do some amazing things and show what have happened sort of in the past, in the recent past, and maybe a few milliseconds before the crash, but it's enough to prove the cause of the bug, right? Or at least narrow down it to a very specific ingredient. So
Yeah.
so there's some easy parts, there's some hard parts.
Yeah, yeah. I think that you're talking about debugger extensions, and I think to me, for pretty much the whole time that I've been on the debugger team, I've had this feeling that the debugger extensions in WinDebug are its biggest strength and biggest weakness because, like you said, it has a steep learning curve. And so, sure, there's a lot of power in there, but it takes a long time to learn that. And I have to assume, how did you learn these extensions? I learned these extensions by watching other people, hearing from other people what extensions. Yes, there's documentation for a lot of them, but knowing what debugger extension to use, knowing how to use it, a lot of times is, not something that I can just teach you from, a book or something like that.
Yeah.
How did you find yourself like learning these things or similar tools?
So that's a really great point. And what sort of my kind of philosophy, if you will, about all these things is when people ask me, how do you learn to debug Windows or Windows crashes and whatnot. um, Debugging is really you just trying to figure out what went wrong, right? That's really like debugging is a cool term, but it doesn't bear what kind of system you're looking at. Any complex system, right? You could be trying to figure out what's wrong with a car or air conditioner or computer system, right, or software system. You're just trying to figure out what's wrong, and the only way to do that is you have to know how it's supposed to work in the first place, right? How it was supposed to work. And it helps very often to know principles because it kind of spares you from learning a lot of details, right? So as you, for example, write a lot of software and you read a lot of software, you become very good at understanding, basic principles of designing software. And so it helps, you're looking at something and you say, oh, that looks strange, right? Let me dig a little bit deeper in there. So debugging Windows is no exception. So my main thing is to learn it is you got to learn how Windows works. And there's some kind of ways to do that. People sort of always assume, oh, it's a closed source operating system. It's not quite that close as sometimes people believe. There are a number of great sources available of learning a lot about Windows, even if you don't have access to its source code. So there are, great books like Windows Internals, right? I read every single edition of that book, and some of them multiple times. There are, great books about Windows drivers, and if you debug Windows crashes, it's absolutely must have knowledge. You have to learn how drivers supposed to work, because usually I would say 80-90% of all crashes that occur um, in Windows environment are caused by device drivers, and usually it's not Microsoft device drivers. So there is that. And a lot of times, those things kind of teach you how to, there's some cool debugger extensions and things like that. There's lots of security researchers nowadays that go and reverse engineer things about Windows, and they publish blogs and articles, and you can read those things. And do not underestimate the power of Windows Debugger help. The built-in help is incredible. And very often there's a great suggestions there about debugger extensions, how to use them, and things like that. And then there are tricks. Sometimes you can take a debugger extension, it's a DLL, and you can reverse engineer it and see what it does, how it works. And um, um, the well-written debugger extension would go and say, oh, uh, debugger engine, right? Give me the definition of this data structure type, right? And you can see it, and you're like, oh, that's interesting. What is in this type, right? So let me DT that in the debugger and see what kind of fields are there, and read those fields, and then, oh, here it says power state. Oh, great! That's what I was looking for, right? So there is, or you would see something like, for example, in the um, PCI.sys driver, there is at some point in Windows 10 was added a log of config space access, right? And so you go and you just look in the debugger and you see, oh, there's a log, and so that's interesting. Is there a way to find out this, right? And so you start digging, and you find, oh, there's extension which prints that, right? And there's some other things. So, for example, um, autocomplete in the debugger, right? So you start typing and you just like see, oh, is there anything else, right? And so it suggests you there's this kind of things. Another kind of trick is in a so debugger extensions are DLLs, right? And so you can take a DLL and find out all the exported functions, right? And so every extension command has to be exported function. And so you can find out all this exported function, including undocumented ones, right? And you start typing and you start like, okay, can I make you do so, or like, does this sound interesting? If that doesn't work, that's when you start debugging the extension or reverse engineering extension to
Yep.
see, like, what does it do? How does it do it? And
Yeah.
or easier, you just go on a web search. I use Bing, but um, anyway, so you do whatever what works for you, and you start like, hey, maybe somebody else figured it out, right? So there's those
Yeah.
kind of things. But I gotta admit that well over half of everything I know, as far as like specifically debugger tools and extensions go, I learned in WinSC by watching other people, how they do things they do, and they taught me a lot, and I kind of kept notes, and that's sort of what I do. Some great engineers write very kind of precise and detailed debug analysis reports, And if you work in a team like that, you tend to read those and read the bugs, and you say, "Oh wow, that was great." Now let me take some notes because that can be helpful in my future, right? And so over time you build those things. I try to get access to whatever I can, and learn as much as I can, learn from others, and but there's
Yeah,
probably every week there's something I'm like embarrassed to admit. Oh, how come I didn't know that, right? And so
yeah,
there's
yeah.
something new command or whatever.
I think it's really. I like when you talk about learning from other people's debugging sessions, other people's debugging notes and stuff like that, and that's something that I've tried to do a lot more of because I've realized that it's very hard to teach debugging skills, teach debugging mentality in a vacuum. You need to be using real world examples. And so I've started taking a lot of times when I'm debugging something, debugging a problem in the debugger, for example, that's what I do most of the time. I try to take really detailed notes and I try to share that with people on my team, more junior people, and get them to learn. And that's something that I would say anybody that's wants to get better at debugging, or anybody that wants to help people on their team or at their company to get better at debugging is do those analysis. Practice at writing these things out, sharing your notes, doing it in a way that you can teach people what the line of like the thought process that went. And there's an aspect of technique, and there's also an aspect of mentality. Just the other week, we've got a pretty junior person in my team, and I taught them about that. There's this flag. There's this tool called G flags. You can enable a bunch of different things with that. One of the most important things, and I've tweeted about this before, is the, loader snaps. Right,
Yeah.
loader snaps is this super valuable, huge amounts of logging that you get from the DLL loading mechanism in
Yep.
Windows. You get insights into what the loader is doing, and you get insights into what the loader is doing when things fail. And it was really great because I taught him this technique, and then not a week goes by, and he says, "Hey Tim, I put loader snaps on, and it's telling me that there was no export table." And I'm like, "That can't be true." And I look at it. Yeah, there's no export table. Okay, let's go talk with the
Yeah.
compiler team now. Um,
Yeah.
but that's really great, right? And of learning from those real world examples. I can't teach you Windebug. I can't just get in front of a blackboard and be like, "Here's how you use Windebug,"
Yeah.
right?
Yeah.
Um, and it's such a broad space. I don't do debugging 101 type talks anymore because it's just so broad. I need to teach you in the context of what you need to debug,
Right.
right? Um, so I think that's really great.
And it's also different depending on what you work on, right? Like if
Yes,
there's a whole set of tools and techniques that you would do to debug complex user mode problems versus kernel mode problems, and um, you might be using the same tool, Windows Debugger, but you will be using very often very different extensions, and you would be looking at different things. There might be some similar things like if you want to look at the call stack or a memory or registers, but other than that there might be very little overlap. And I agree with you that the approach I use is very similar. There is a great book by Mark Rusinovich on sysinternals tools, which is another great set of tools to use in debugging, and very often kind of underappreciated. You can learn a ton about system behavior, and you can learn a ton about what's going on by using tools like Procmon, for example, right, or Process Explorer.
absolutely. Yeah, yeah.
And so we use those as well. And I have a debugging class, and in my class, I basically I have a collection of dumps as over the years. I go when I debug something, I look at something, I say, well, that this is a great dump because it's kind of time constrained, right? Like I don't want to use in a class something which takes 2 hours to debug because everybody's gonna forget, right? So I try to keep it, within 20 minutes or so,
Mhm.
and but it's going to demonstrate some important technique, some set of commands, good extensions, and kind of good techniques. And so I collect those, and those are all real life problems, how they would happen in real life. And this is the best, obviously, as opposed to sort of artificially created examples of crashes. they often too simplistic and not realistic enough to actually teach something. It might be good enough for kind of one-on-one experience, but not really complex enough to learn something for real. It like anything, it takes practice, it takes work, definitely. But as you said, it's nearly impossible to sort of teach somebody that. You can expose folks to the knowledge. To You can show, hey, there's this kind of things, there's this kind of set of commands and ways to discover them and all that stuff. And this is some examples of how I do it, right? Um, but you still it doesn't work without good background in the how the system's supposed to work, right? So I always tell everybody, uh, if you work on Intel systems, read Intel software developer manuals, all 5,000 pages of those. You can skip 3,000 pages where it goes about instructions or something. But volume 3 is system programming is the most important
Hmm.
one to read, and read Windows internals. And this is a dense books, so it's probably a good idea to read them a couple times. Um, and you start looking at the real problems, and it kind of helps, right? You learn a lot. You learn a lot from other people, and this kind of things. We try to write our debug analysis reports. So something I learned. There was a guy I work with in Microsoft, Andrew Rogers, and he was the best at writing debug analysis reports. And the rule is that you provide all the necessary commands which were necessary in your investigation with parts of the relevant debugger output, right? So you cut out the kind of excessive stuff which was not relevant. You put the relevant parts in, and you explain what is it you're doing, why you're doing. And the rule is that somebody else should be able to open the same dump and follow your footsteps, type the same commands, see the same output, right? So there
Yep.
should be no tricks, no, magic, like you should be like, if somebody, they type bang thread and something, right? And they give it address of a thread. You should be able to find it in the previous debugger output, that address, right? Like, where did that come from,
Yeah.
right?
You know what I do for that is, I don't know if you use
We
Winbug Preview
highlight,
much.
yeah, we
The
highlight,
highlighting view, you do
yeah.
control double click. And the
The
nice part about
the
that, you copy and paste that into OneNote or into an email, and you're gonna see, and now you start seeing where all these pieces connect.
So the new Windows debugger, which I'm embarrassed to say we don't use exclusively, we still
Okay.
rely quite a bit on a legacy one, and if you're interested, I can tell you why. But the new Windows debugger is absolutely incredible because that highlighting feature, it's not helping just with the preparing the output. And by the way, another cool thing about that output is that you can copy paste it, and it right away has a correct font, meaning that it's not um, uh, uh, um, it's a fixed width font, right? So when you create debug analysis, right, the text that you write is optimized for reading, but debugger output needs to be fixed width font, because
Hmm.
that is actually optimized for reading for that part, right? So Windows debugger, the next version is absolutely incredible in that. And that highlighting feature is is insane. People don't realize how good it is, because you double click on something and it highlights it, and all of a sudden you yourself see, oh, it is in here. I didn't even know that, right?
Yep.
And so that can be a time saver of incredible. Just sometimes exposes you to the things. Like, I was debugging something, and I had to, I had to kind of, there's a feature in Windows which allows you to in Memory Manager, if there is like a leak in your locked debuggers, drivers can lock memory, right? And so if we forget to unlock it and the process terminates, that's not a good thing. And so memory manager complains, and you can enable kind of tracing of that, and it creates sort of a data structure, which is kind of tree-like data structure and all that, right? And so you can traverse it, by hand and find out and everything, right? And then I was traversing that, and I double-clicked it, and then highlighted it. To my embarrassment, the thing I was looking for was provided to me by the Bang Analyze extension already. So I could have saved about 20 minutes of work by not doing what I was doing. That's by the way, another interesting thing that I met more than once people who, like I say, how do like here's a debugger, here's a memory dump, show me how you do your things, right? And we start doing things, and it's always shocking to me when we don't start with Bang Analyze, because
Mhm.
what folks don't realize it. There's a dedicated team of engineers in Microsoft who are incredible at what they do, and they write this Bang Analyze extension. And all you have to do is to type Bang Analyze -v for verbose, and it will do. In some cases, it will actually pinpoint and root cause a bug for you, but in many cases, it will provide you lots of great information to proceed, and you kind of understand what to do next, or what kind of hypothesis maybe you can work out, and all this stuff.
Yeah.
So there is that. So new Windows debugger has this things which might appear, oh, it's just like sort of UI convenience stuff, right? But the value is incredible. If you have to stare at a whole bunch of hex digits, right? This kind of features have incredible value, because it's difficult to spot sometimes, and you double
Yeah.
click and all of a sudden debugger says, hey, it's right here, and you're like, oh, that's great. Right? So apparently that is stored in this data structure. I didn't know that, so it's
Yeah.
very convenient. So
Makes me really happy to hear you talk about that. I don't know if you realize this. I was one who started the new Windebug project about 6-7 years ago, and part of it actually came out of things like that highlighting feature. And so that highlighting feature, just to give credit where it's due, that came out of the escalation engineers. And so on the old version of Windebug, they had created this debugger extension that had implemented this highlighting feature. And I looked at that and I said, how'd you do that? There's no API for that. And I look at the code and I see they're like reaching into Windebug internals
oh
and they're going and manipulating stuff. And I'm like, oh, that's awful. But at the same time, I realized there was a need for that. Okay.
right,
And so if we couldn't give that to them with the old Windebug, with the legacy code that
yeah.
I think I just figured out, first version was released in 1993, I believe. Version 3.1 was released about then.
So
Um,
corresponding to first release of NT.
Exactly. That's right. And so, if we couldn't give those types of features, that meant we really needed to, step up our game and do some of this work. And so that was among many motivations. We wanted to make sure that we have that really, really good command window experience, because that's the bread and butter of Windowbug, right?
Yeah,
Lots of other windows are useful, but, you know, to get the real value, it's all of those analysis that's happening from Bang Analyze. And on the Bang Analyze note, right, it is a great tool. And the thing I love the most about Bang Analyze, it lets me speed through the not interesting bugs, right? Gets me
right.
straight to the answer in those, and I can spend my time on those really gnarly, what I think are the fun bugs, right?
Yeah, and we do sometimes things which are if you don't know, you might not even think about it, right? And they do
Yeah,
know, and so if it's a kind of problem you're not familiar with, they might expose you to something, and they keep extending it. They keep finding some patterns where they can expose some additional information, and it's incredibly useful. I spend most of my time, pretty much 100% of the time, inside the command window. I almost never use any other windows, and the reason for that predominantly is because everything I type, I want to be able to copy paste in my report, right?
Yes,
And
absolutely.
and it's also uh, it's also searchable, right? So
Hmm.
you can search it in a text, or if it's a lot of stuff, you would create a log and you put things in a log, and then you use things like grep or whatever to filter things out and stuff like that. So it's kind of I prefer command window for those reasons. Another thing which people sometimes don't realize, they type commands in a debugger and it shows them stuff, right? But debugger is inspection tool, right? So if you tell it, hey, this piece of memory is a string, right? Format it to me as a Unicode string and do DT, Unicode string, here's an address, right? Debugger will do it for you whenever it is Unicode string or it's something else, right? Debugger doesn't know necessarily what it is, and so it will do what you ask it to do, right? When you look at the registers or whatever, if you're not in the right frame in a call stack, you might look at the wrong register value, right? Like that stack pointer is not actually where you need to be, but you forgot to switch frame, right? Or something like that. So when you're in a command window, um, you're in control. So you're doing things. Of course, you have to be aware of the fact that you can yourself make a mistake, type a wrong address, switch to your own frame or whatever. But you get used to that because I cannot trust myself, right? So if I see something strange, I have to double check first of all, did I actually do the right thing or not, right? But I never just rely on a debugger doing it for me, right? I want to do it myself, and I know if I double check everything, and very often, like when we talk about breadcrumbs, right? You're trying to find an independent way of kind of proving the same information twice, because that reduces probability that something happens sort of differently or by chance or whatever. And by independent way, I mean truly independent, right? Sometimes people say, well, this value is blah. I can prove it by typing DT and using this debugger extension. Well, that debugger extension looking at the same piece of memory. So of course it will show you the same value. That's
Right,
not
right.
independent, right? But there's some, other ways, like, for example, I don't know, what would be a good example, like an Urkel value, right, could be saved inside kernel data structure and could be also present in a control register in the processor. So if you look in the live system, you might be able to actually uh, see it twice, right, in a different way. And so and it proves it that it's really what it is. So there's
Yeah.
stuff like that. But yeah, control window experience is amazing. And um, even the old debugger has this feature called debugger markup language, right?
Hmm.
DML. And that was when that was added, that was a game changer, because nowadays a lot of times folks code those extensions. It's pretty amazing. You can debug half the time just by basically clicking, on the things using your mouse, because they already figured out what's the most common thing you're going to look at anyway, and so you just click.
Yeah.
And so people who write extensions, they write those debugger markup language links that you get to click on, and they do something cool for you, and all that. And we have some folks, like there's a guy on my team. He actually uses old KD interface, and
Hmm.
he still sees uses just KD interface. So he has no choice but to use command window. Basically, that's what he used. Uh, for. But all these different interfaces, we all rely on the same engine, and all these improvements that you guys do, and they suddenly appear, everywhere. And even though when we use legacy debugger, a lot of the new features come to the engine, and it helps, right? Because it doesn't matter if you use, next debugger or legacy debugger, you get fixes or improvements. Extensions work the same way, and some of the features available. Some of the new stuff, I have to admit, is I haven't learned that. They kind of the query capabilities that you added are they seem like so much power in this. There's such an amazing things you can create from that. But I'm very sort of primitive user of those. I've only started to use them because there's a lot of things that you learn and it kind of in your muscle memory and you prefer to do it, in the
Yeah.
fastest way possible. So I'm slowly learning, slowly adopting, and this is the reason why um, Windows Debugger Next is not my primary tool yet. I use it more and more every month, but I still use a lot of legacy debugger.
Yeah, I think the thing that's a big selling point for some people is, when they need to be analyzing or searching through larger, chunks of data. And that's where you start to get these queries. And that's where now in Windebug preview, in the newest version of Windebug, right, we've got this little script window. And yeah, not everybody likes writing JavaScript, but I'll tell you, sometimes you get a few lines of JavaScript to go and analyze some data, and you've just saved yourself an hour worth of sorting and sifting through the data. But it depends, right? And everybody is solving different types of problems. And I've noticed that and I see this all the time with, we have different types of customers that are doing different types of debugging with Windebug, and some of them only see their specific world and they think, why would you ever want to do this, why would you ever want to do it that way, right? I think very similarly to you in that command window is where I live, right? I want to have that trail of information. I want to have all of that, the record of what I've looked at, so I can look at the breadcrumbs and see and verify, right? There are people that use Windebug and they just use the source window and the
Yeah,
breakpoints window. I
yeah,
don't I don't get it, right? I don't completely understand it, but I'm not going to tell people how they should solve their problems, because everybody's solving a different type of problem. For some people, right? I see Yard and Shafir talking on Twitter all the time about, she's written these JavaScript extensions and using the data model, and it's just doing some amazing things of just, getting that needle out of the haystack for the problems that she's looking at. And of course, that might not be relevant to somebody who's like, they're doing crashes where, 9 times out of 10, you've got to go and look at a frame that's up on the stack, and then you're going to look at the disassembly, and that's how you do your debugging, right?
oh
And
yeah.
so I continually learn there's no one right way to use Windebug. There's no one right way to use KD, right?
It's such a powerful tool. The
Yeah,
capabilities that, especially with Windows Debugger Next that you have created, it is an incredible tool. It as far as debugging experience, if you know it, some people hate debugging. Some people say that they love debugging until they try to do something like I do, where they have to debug somebody else's crappy code that we never seen before. But as far as debugging experience goes, Windows and Windows Debugger combined, right? And people kind of don't appreciate it. Windows itself has a built-in kernel debugger. It's part of a kernel, right? Windows Debugger provides an interface to that debugger already, and that experience is the most powerful experience of all computing systems. Basically, so far in anywhere, you cannot get it anywhere better. It might have a little bit of learning curve, but once you get a little bit comfortable with that, the abilities that you get are absolutely unparalleled. And with Windows Debugger Next, it gets improved with every version very, very rapidly. There's more and more things. And you mentioned Yarden. She's If you're not following her, you're missing out, because she is absolutely incredible in the things that she writes about Windows internals. It's like one of the big sources of incredible information to learn. And I think she is probably outside of probably you and your team. She may be the most skilled user of WinDBG Next, basically with all this scripting stuff and the things that she does. It's just amazing to see the kind of stuff she's able to pull out in queries and the things. I look at this and I'm like, wow, you got to have a PhD
yeah,
just to read that. Um, but it's the power of those things is incredible and amazing that you can do, especially when you have to like you said, deal with bigger data sets, bigger, data structures, and some of the things nowadays, kind of sort of it was hard to imagine just some time ago. We get server systems with more and more cores, more and more processors, right? And so when you get 8 socket system with a whole bunch of cores per socket, you start looking at the things. Can you imagine how many threads are simultaneously running? How many, processor control blocks are there and everything, right? We're talking many, many hundreds,
Yeah.
right? And so you start looking at this stuff and you're like, wow, that's, I don't want to do it by hand. That's too many, too many threads, too many call stacks or whatever to look at. And this is where it's probably a good time to start writing some queries and kind of automate that. And the features in that query language and then new debugger. This is something which was not available and not available in a full way kind of legacy debugger. The power of that, especially when you have to deal with a lot of problems with a lot of complex things to debug, you cannot put a value on that. It really saves a ton of time.
Yeah, yeah. I'm always really impressed when people, outside of Microsoft, people like Yarden, people like Alex Inescu, folks that have learned a lot of these things without necessarily being, inside Microsoft and sort of, you know, people inside Microsoft are sometimes just sort of forced to use WinDebug. It's not always out of choice. It's like maybe it's the only tool that you've got, right? But I think it's really impressive to see people that are like completely outside of that sphere that just get so good at using the debugger. And you're right, Yarden's one of them. There's a couple of people I follow on Twitter that I'm just really impressed with the sort of the power that you get out of it. But I think that's the thing, right? It's a bit of a blank slate. It's a bit of a canvas for people to use the debugger how they want, and that's something that I like about. I'm biased, of course. I like the debugger that my team works on, but everybody's going to use it in a little bit different way, and that I think is one of the differences between some of the other debuggers. And I use Visual Studio Debugger like all the time. I do a lot of application debugging. There's totally a a great fit for that for certain types of things. Like when I'm debugging the UI, when I'm debugging WinDebug UI, I'm doing that in Visual Studio most of the time. That's a .NET application. I'm going to press F5. I'm going to set my breakpoints. If I've got a
Right,
problem deep in the engine, I'm probably not going to use Visual Studio, right?
right.
Um, and for WinDebug, what I think our philosophy tends to be is I'm not going to tell you how to debug your problem. I'm not going to tell you you've got to go and hit F5. I'm going to give you the tools that you need to go and solve those problems. And so there's a million ways, and that's contributes to the learning curve. Like you said, it's a steep learning curve, right? And part of that is because it's a blank slate. There's a million different ways that you can approach these problems.
it
But
it has so many capabilities, and it allows it provides access to the system in so many ways, right? So when you're looking at the live debugging, um, there are ways that you can do, right? Some might consider unnatural. So it's you cannot do them in Visual Studio, right? If you in kernel debugger, you get access to control registers, model specific registers. You can do things that there's no other way to do other than using this kind of tool, Windows debugger or sometimes hardware debugger, right? So um, this is Visual Studio is great. I always say if you debug in your own code, if you wrote some user mode code and you debug in your own code, probably Visual Studio is a way to go, most
yep,
likely. Um, if you debug in somebody else's code, if you debug in some interaction with something else, or if you debug in kernel mode, then Windows Debugger is your tool, right? It's you can open a dump in Visual Studio, you can do some things, but it's just not, it. Windows Debugger is not a Swiss Army knife. It's It's basically a Home Depot of tools. It's you walk in, there's everything in there. I mean, you can do things, you can do incredible things, right? Like
Yeah.
I, if I debug live, I can write a patch, like literally, right? In assembly, I can go and say, okay, um, I want to create. So let's say, you want to set a, breakpoint somewhere, right? And it's a very hot spot. So if you set a breakpoint, and for example, I want to set a breakpoint on, accessing, some data structure or whatever, right? And it's some API. That's where I want to set a breakpoint, but it gets cold all the time, right? So I can create a conditional breakpoint, and that will work. Um, and in many cases, that's very good, right? Debugger has support for conditional breakpoints. You can put a little script, and that will work, right? If it's very, very hot, this will be extremely slow experience. And if you're dealing with something like a race condition or whatever, right, it might just disappear,
Yeah.
or it might take hours, to hit it or whatever, right? I can create a patch. I
Yep.
can literally go and find some blob of memory, and I can modify code to jump into there and write a little assembly program which compares some register to some known value. And if it's not there, then I jump back, and otherwise, so I can basically hack things around. Hopefully I get it right, otherwise we'll crash. Uh, but this allows me to basically do things like in a runtime, right? So then I rely on the power of a processor to execute few assembly instructions. Yeah, it's a jump, but comparing to conditional breakpoints, when we exit to debugger and it evaluates my script, we're talking about thousands and thousands of times faster, right? So ability, you have everything, right? From a screwdriver, from a basic screwdriver, the stud finder, and all that. You have your, huge saws. You have all your materials. You can rebuild everything. It's all depend
Yeah.
on how much time and effort you're willing to put in it. So Windows Debugger is much more than just debugging tools. It's really sort of a set of capabilities which is unparalleled, unmatched, and a lot of that stuff is easy to use, and a lot of that stuff takes time to figure out. But this is a reason why good security researchers, right, who go and kind of investigate how Windows does things and everything, like Yarden, for example, right? They complement static reverse engineering with dynamic studying of how system works using Windows Debugger, right? So
Yeah.
you can learn things about Windows using Windows Debugger, and kind of observe things how they happen and everything, and um, look at the data types and look at runtime behavior, for breakpoints and whatnot. It's it's a lot more than a tool. It's really environment to live in.
Yeah. Yeah. So I don't want to take up too much more of your time, but we've been talking a lot about WinDebug, and you've mentioned a couple other tools like Hexrays, and we talked a little bit about Visual Studio. What other tools do you use that you think somebody should go and like? You want to get really good at debugging. What's another a tool or a couple tools that you think are worth learning?
Sysinternals,
Yeah.
absolutely. All the tools in sysinternals worth to install and um, kind of get to know very well, right? Primarily, it's going to be Procmon and Process Explorer. There's a two most important tools in sysinternals suite. There is that. Visual Studio has a bunch of useful tools, right? So just give you some examples. You get like a message box saying something went wrong. What was it? I don't know, right? Use Spy++, find out a window, find out who it belongs to, right? So there's this kind of things. Um, Visual Studio Linker, right, has a built-in disassembler, right? It's a batch disassembler. It's, so it's not kind of as powerful as Hexrace, right? It's not as sophisticated. It's a batch disassembler. It does a job though. and it does it pretty good. Although if you like sort of disassemble one function, use WinDBG UF. That's much better way because it splits it in the basic blocks. It's easier to
Right.
to
Right.
follow and everything, right? So um, or complement it, right, and all that. But that's this is a kind of thing. So that's probably in addition to Windows Debugger. It's sysinternals and Visual Studio tools are probably the most important. Windows Debugger has a bunch of executables shipped with it. I
Mhm.
highly recommend everybody go and inspect what we do because many of them are unlocking capabilities, so built-in capabilities of the operating system, right? Like G flags is basically allows you to turn on some of the built-in stuff into Windows, right? So Windows itself has pretty amazing things. And then last but not least is ETW tracing, right?
Mhm.
Collect tracing and use Windows Performance Analyzer to look at the traces. Very often you can learn um, what happened, right, and this kind of thing. So these are probably the tools I would recommend. If you ask me what I use in addition to that, some of the kind of important things, which unfortunately not accessible to a lot of people, is the hardware debugger, right? So
Mhm.
we get access to what's known as JTAG debugger, and you use that when your processor is no longer running, right? So you can have a problem and you need to figure it out, but your computer is no longer working, right? There is no operating system doesn't work. You cannot use Windows Debugger easily, and you need to find out what happened and why. And so you're looking at the dead corpses of a processor, and its registers are not accessible, but things in memory sometimes accessible, and some of the physical registers might be readable. And you look at remaining ashes of what happened and trying to piece together what might have happened. So that's another powerful tool that I use.
That's great. Well, thanks so much for spending time with me, Ivan.
Sure,
I've
that
learned a
was
lot.
fun.
I'm sure people watching will learn a few things. It's always really interesting. I find it amazing to hear about people whose jobs are debugging because I just think that's great.
Yeah, I highly recommend anybody, if you want to know more about Windows, read Windows internals, read Yarden's blog, and and learn Windows Debugger.
Great. Thanks, Ivan.
Thank you.